So in class, we looked at how we would type in permutations and combinations in our calculator. Now I want to show you actually how we will work problems with these. So permutations are problems where our order matters. Combinations are when they do not matter. So we're going to look at some of these guys right here. So we know how many different ways could we have first, second, and third place finishers occur in a race. This tells me right here that order matters. First place is different than second place. One person gets gold, another person gets silver. So this is a time when order matters. When order matters, I'm going to use a permutation. So this is going to be a P, and we're going to type it in the way that we practiced in class. So if we type that in, we get out 120. And remember, I have those directions posted on our Moodle page. And if you want to see a visual, then you can just Google the name of your calculator and then permutation. And there's so many videos to show you how to type it in. But we also is what we practiced in class. Now, permutations are kind of neat. They have more than one way that you could type them in. So that's our permutation way. You might also think about it being that 10.2 way though, the fundamental counting. You kind of think about it in terms of that. It's not technically a fundamental counting, but we could work it similarly. So if we had 6 runners, when they first start the race, any of those 6 can win. So we have 6 choices. But then once one person crosses the finish line, there are only 5 runners left to be in second place. And then there are only 3 runners left. And that's first, second, and third place. So that's all 3 places. I don't actually see that number 3 written, but I see those 3 numbers there. I think my pencil stopped working, so let me come up here. And there we go. So I can type either one of these in and get 120 for my answer. Here we've got another example. We've got some books here. We can only fit 10 of our 15. And in this one, it has another like key thing to me. We've got the word arranged right here. So that tells me that order matters. So order is important again. That's going to be a permutation. My largest number is always going to come first. If you put the other one first, you're going to get a funky answer or an error in your calculator, so you'll know it can't be. Now this one, you definitely want to type in your calculator so you know how your calculator is going to show you. It's going to give you what scientific notation. So most calculators are going to have this funky little E thing. Let me just write out exactly what my calculator gave me. This E to the 10. Basically, it just means the number is so large that your calculator can't write the answer out. So this E stands for exponent. Kind of how we normally write this would be times 10 to the 10th. That 10's the exponent there. But it means we're going to move our decimal place over 10 times. So my decimal's right here. 1, 2, 3, 4, 5, 6, 7, 8. And then 9, 10. So that means I have to fill in anything extra is going to get filled in with a 0. So those are 2 extra loops. So that's my answer. Let me see if I can. So 10,896,286,400 different ways we could arrange those books. Now we're going to want this answer down here that I've got boxed in. If you stop with the E to the 10, you will not receive full credit, right? You need to be able to look at that scientific notation and write it in what's called standard notation, what we've got in the box. My math lab's going to treat it the same way. All right, so let's look at some spoiler alert here. We're going to look at some combinations here. So we want to know how many ways can a sample of cell phones from a shipment be pulled. So a sample, the order doesn't matter. So the sample right here, it does not matter. So you're just going to pull out any 5, the first one that you pull out and the second one you pull out and the third and the 5th one, you're going to do the same thing to all of them. The first one isn't special. You're going to treat all of them the same. This is going to be 20, 5C5. Now, there's no way we can't multiply 25 times 24 times 23. We can't do it this multiplication method down here. We've got to use our combination button on our calculator. So if we type in 20, and I said 25, there are 24 cell phones. Let me fix that. 24C5. There are 24 cell phones and I'm picking out 5. So it's going to be 24C5. So if I type in 24 combination 5, I'm going to get out 42,504. This next one is another example of a combination. When we're passing out cards, unless it says otherwise, but usually doesn't, cards, you can change the order in your hand. Like if you think about playing any sort of card game, even like Go Fish, you can change where the cards are in your hand. You can rearrange them. So the order does not matter. So it does not matter. So we're dealing with a combination again. You didn't have to know that before now. I'm telling you now. We're dealing cards. The order is not going to matter. You can rearrange them once they're in your hand. All right, so there are 52 cards in a deck, and we are going to choose 5 of them. So it said there are 52 cards right there, and we're picking 5. So I would do the 52 combination 5. So 2,598,960. We're going to practice some more of these on the next page. We've got some problem solving hints down here. 10.2, we went over that fundamental counting. Fundamental counting stands out because you can repeat right here. So there are basically 2 questions you need to ask yourself. Can I repeat? If you can repeat, then you're doing that fundamental counting where it's just the numbers multiplied together. So maybe like we're flipping coins, 2 times 2 times 2. We're just going to multiply them together. If you cannot repeat, so the first question is, can you repeat? Answer is yes, we're going to do the multiplication. The answer is no. You're going to ask yourself a second question, does order matter? If order is important, so if order is important, order matters, it's permutation. If order does not, it's combination. So again, 2 questions. First one, can I repeat? Yes, work the problem. No, ask yourself the second question, does order matter? Yes, it's a permutation. No, it's a combination.